Hi, my name is Po-Chu, and today I'm going to explain how to solve this question, the Motorcade problem. So let's first read the problem. The problem says that Ihan is leading a motorcade, which is a list of trucks, for a transportation task in the mountain area. And in this area, there's an old bridge on the road. It is old, so the total weight for all trucks crossing the same time is limited to the big W. So let's simplify the problem. Let's say Ihan has to lead the motorcade from A to B, and there's a bridge between A and B. And the weight limitation of this bridge is the big W. And because the problem say it has a list of trucks, so maybe I have a truck I with the weight I, and so that maybe truck 1, the weight I will be 40, and the 2 will be 50, and 3 will be 50. Then the total weight that the truck passed the bridge cannot exceed the big W. That's pretty intuitive. So let's continue reading the problem. The motorcade has N trucks, and each one has a speed SI. Okay, NWI. So each truck has a speed SI here. What happened? SI here. Maybe the speed for the truck 1 will be 25, 20, 20, etc. And Ihan decided to partition the motorcade into some groups based on the original order of the trucks. And for each group, the total weight of all trucks is no more than W. So intuitively, and they travel by the lowest speed for all trucks in the group. So let's imagine if I want to let the truck 1, 2, 3, let them all pass the bridge. So the total weight of these 3 trucks will be 50 plus 50 plus 40 is 140. And what is the speed of these all 3 trucks? It depends on the minimum speed, because we can imagine intuitively, and the fastest trucks must follow the pace with the slowest trucks. So the speed of this group will be 20. The minimum was the speed and the W. So in this problem, Ihan want to minimize the total time that the entire motorcade, the N trucks, need to cross through the bridge. So how do we solve this problem? So at first time I want to solve this problem is that I want to use the greedy, because I got 2 constraints, kind of. We have the weight and we have the speed. So maybe we want to use the given weight limitation. I want to choose the speed as fast as possible to minimize the time. But in this problem, intuitively, why the greedy approach cannot work is that because these parameters might be dependent to each other. So you can imagine, maybe you can combine some trucks, even though they are really slow, but their weight are really light, so you can let many of the trucks pass through the bridge on the same times. So that's one of the intuitive reason why the grid approach will not work. So if the grid approach cannot work, then we will try to use the dynamic programming to solve this problem. And for the dynamic programming approach, what will be the state that in this problem? So we are going to define the state, the DPI, which we define is that the total time for the first I trucks to cross the bridge. So the DPI is the total time for the first I trucks to cross the bridge. And intuitively, our boundary case will be 0, because if I is 0, it means we don't have any trucks, so we don't have to take any times to let them all pass the bridge. So the DP0 is 0. And we can write down all the DP station, maybe state. The DP0 is 0, obviously, and DP1, DP2, DP3, etc. to DPI. Blah, blah, blah. And obviously, what is the result we want? The result we want is the DPN, which is the final one, right? We want to know the total time for the first n cars to cross the bridge. So until to the DPN. And this number is what we want. Let's consider how the recurrence will work. So let's maybe we want to solve this number. We add this state. How do we solve the problem at this state? The key point to find the DPI is that we need to enumerate all the possible splitting point of J. And if we find this J, we need to know this J can make the first J minus 1 trucks will cross the bridge using the best time they can achieve. And intuitively, I can use this DB table to elaborate more. Is that maybe at this stage, I will try to find the previous trucks and add it into my group. Let's say maybe I find the DP arbitrary, maybe DPI minus 1 has its weight I minus 1 and its B minus 1. I add this truck into my group, into an empty group. Here, we want to add it. And when we add it, we check whether this weight will exceed the big W, the weight limitation. If it will not exceed the weight limitation, then I can split on this point at this point, right? So the first group is the group with the WI, and the second group is the DP I minus 1. The time spent by the previous group, and the post group here that we want to decide it. So we can check from this process recursively. Like this is the first stage. Let me erase all the things. That will make it more clear. I first check the black one, and then I check the red one, and check whether when I add a weight into the second group, is it match the limitations? If it is matched, then I can cut through this point, right? And maybe this point is DP I minus 2. So the first group will become the here is the DP I minus 1 I minus 2 plus the time, and also the previous group is DP I minus 2. I'll keep checking it. Maybe I can check through here, maybe here, and I can also cut it in two groups. The one group is here, and the other group is here. I will keep tracking on this way until maybe I track on this to cut this point, and I find when I add this weight into my total batch, and this weight is exceed the big W, then I will stop, because it means the total weight of this batch is exceed. So I cannot let this batch of trucks to pass the bridge. So I'll keep checking this, the black one, the red one, and green one, and the purple one, until the weight limitation exceed. And all during this process, I was trying to find the minimum time I want to find. So the recurrence, we can write it down, is DPI is minimize the things, that is the DPI itself, and the DP, we want to find some J here, because the J is the cutting point, and with the previous group has a batch time here, plus the maximum time of this group from J to I. And note that here that the time here is the speed, is the length of the bridge divided by the speed, right? So you can calculate here. And also you need to, we have the constraint that the summation of the weight from J to I, their weight should be less than equal to the W. So throughout this process, we want to minimize, capture the minimum number of all this value, like the black one, the red one, and the green one, and the purple one. So that's the basic idea and the recurrence, how we solve this problem. So let's check out the code here. The code is really simple. You can see we initialize a DP array from 0 to n plus 1. And for each I here, for each I in the DP array, we consider all the possible previous trucks, and that could be a valid group. How do we mean the valid group? So for this for this I initialize a total weight equal to 0, and I keep adding the truck into my into my current group and compare to the previous group. And I keep adding it. If the total weight exceed the big W, then I break it. If not, I will keep comparing the DPI here to find the minimum number, find the minimum time I can achieve. And I keep doing it until I got a DPN. So that's how we solve this problem, basically. Now let's doing the time complexity analysis. So what would be the time complexity? We can imagine, because we got a DP array here, and if we want to compute the DPI, we need to check every possible previous group, right? So the worst case is that I need to check all the group, chop all the I minus 1, I minus 2 to 1, right? That would be the worst case. So the time complexity will be the O n squared, because for each I need to check backward every time. So that's the basic idea how we solve this problem. And thanks for your listening. Thank you.